Hello, students. I'm not sure whether y'all can type anything. Can y'all try to type something in the chat so that I know? Oh, okay, great. Okay, good. Okay, that means y'all can actually type something. Okay, everybody say hi to me. Okay, hello, students. Okay, please type hi or hello or something. Okay, or like hey or yo. Thank you very much. Okay, I need a response from everybody. Okay, I know my dear Tristan is here. Okay. 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 What's up? Because just now I saw, how come the chat is like empty there? Are y'all like there or not? Okay. All right, good. Okay. So all right, I'm going to show you a summary first. Okay. Today our topic is area and perimeter. But area and perimeter, right, is not totally unfamiliar. Okay. I think most of you should have already noticed that your Sec 1, right, builds a lot, okay, upon P6. Okay, Sec 1 syllabus builds a lot on the P6 syllabus. Okay. In other words, okay, if you have some idea, okay, on area and perimeter, okay, then I mean not some idea lah, but at least there's a foundation, okay, on area and perimeter, then you just have to build on. Okay, that means you just have to learn new formula. That's all. Okay, the concept is still the same, just that we are going to learn new formula for new shapes. Okay, certain shapes that for example, okay, like a parallelogram, trapezium, okay, a kite. Okay, we are just going to learn the area and perimeter of new shapes. Okay, so let me share with you my slide first. Okay, I share with you my slide. Okay, this one. Okay, so let's just do a quick recap. Okay, so that later on when I go on to the questions, right, you will not be like totally lost to know what I'm saying. Okay, so perimeter and area, plain figures only. Okay, so this chapter we are looking at only not total surface area. Okay, have to differentiate that with total surface area. So this is just 2D figures. Okay, so let's recap. Okay, all these, okay, square, rectangle, triangle, circles should be things that have been covered. Okay, these are shapes that have been covered in PSLE. Okay, so all these are like, I assume you know, okay, I assume you know like how to find area of triangle, half times base times height. Okay, so circle, circle. Okay, I saw students tell me, oh, circles after PSLE, I forget everything already. Okay, I can't remember whether it's 2 pi r, pi d, or pi r squared. Okay, so there's maybe a small mental trick, okay, that I can teach. So if it's area, okay, you know area, right? Unit for area is always like square centimeter, square meter. Okay, always involve a square there. Okay, so the corresponding area formula, okay, for circles would have to be pi r squared, the one that has square. Okay, not just pi d or 2 pi r. Okay, so we will pick the one that has square. Okay, pi r squared. Okay, parallelogram. Okay, area of parallelogram, right? Parallelogram is a flattened rectangle, and therefore, the area of a parallelogram, okay, is the same, or rather, the formula is the same as that of a rectangle. Okay, base times height. Okay, because a parallelogram can actually be transformed into a rectangle. Okay, so for those who have attended the MAP program, right, or those in my regular class, okay, I would have taught you like how to transform this parallelogram into a rectangle. Okay, you can actually cut certain parts of it and then shift it, okay, to the other side to fill the empty gap, and it turns into a rectangle. Okay, rhombus. Rhombus is a flattened square. Okay, it's like a flattened square like that. Okay, so the area, okay, area is also base times height. Okay, just like a square, okay, base times height. Okay, because a rhombus, right, for a rhombus, all the 4 sides are equal. Okay, so to find the perimeter, you just take 4 times of the side, of the length of each side. okay, the length of one side, then you times 4. Trapezium. Okay, trapezium is slightly more challenging, okay? Actually, right, until now, I still have students who get confused, okay? Trapezium, okay, trapezium. Okay, do take note. It's half times the sum of the two parallel sides, the sum of the lengths of the two parallel sides. So when you look at a trapezium, right, you have to first identify the two parallel lines, the two parallel sides. Okay, you name one as A, the other one as B. Okay, so half times the sum of the parallels, sum of the lengths of the parallel side, so A plus B, then times the perpendicular distance between the parallel sides. Okay, we are talking about perpendicular distance, okay, 90-degree distance between the parallel sides, so H in this case. Okay, it may not necessarily be a height. Okay, height, we always assume is vertical, right? Vertical, then is a height, right? But in this case, okay, this height that we are talking about may not necessarily be a vertical height. It could be just a perpendicular distance. Okay, it's just a perpendicular distance. Okay, can? Okay, somebody asked, is a parallelogram a type of trapezium? Interesting. Is this Kendrick? I think this yes, I know. Okay, this is Kendrick. Okay, there are different schools of thoughts, to be honest. Okay, trapezium, right, is defined by a shape with a pair of parallel lines. Okay, a pair of parallel lines. So long as the shape has a pair of parallel lines. Okay, so that's the definition of a trapezium. So then you ask yourself, okay, does a parallelogram have a pair of parallel lines? Okay, so if let's say it has, then it will be classified under that. But there are different school of thoughts, okay? Some people, okay, some scholars say that, oh, trapezium must have only one pair of parallel lines. Okay, but some says, okay, so long as there is a pair of parallel lines. Okay, so the issue lies in this, whether it's like strictly only one pair or it's a pair. If it's a pair of parallel lines, then a parallelogram, okay, because it has a pair of parallel lines, that will be classified under that. But if it's strictly only one pair, then no. Okay, but then again, there are different arguments. Okay, there are different arguments. This thing, I know this thing has a lot of yeah. Okay, it depends on a different school of thoughts. All right. Okay. So parameter, right, the sum of all the four sides, okay, the length of all the four sides, okay, give you the parameter. But the thing is, usually, okay, in your Set 1 syllabus, right, you will have to know, okay, the two slanted lengths will be given, okay. It really depends on the school. Some schools, they teach Pythagoras theorem in Set 1, okay. Some, like, usually it's the IP schools, okay? They like to pull down certain concepts, so they teach in Set 1. So maybe length C and D will not be provided. So they will ask you to find, okay, to find length C and D. Okay, that is possible as well. Okay, it really depends on like, you know, how they want to pitch, okay, at what level they want to pitch the paper. Okay, so but in most schools, okay, don't worry, the two slanted lengths will be given. So you just have to add all the four sides together. Okay, okay, up to here. Okay, so today we are just going to cover this part, okay? We are not going to cover volume and total surface area. Okay, course of just 1 hour, okay? Time constraint. Okay, let's look at this. Okay, can y'all see my screen, this thing? The worksheet, okay? If you can see the worksheet, okay, please say yes, okay, so that I know, okay? Good, Ashton Lim. Oh, I see Garrick. Oh, Garrick is online. Oh, wow. Okay, awesome. Okay, good. All right. This diagram, okay, shows a company logo, okay, in the shape of a square, ABCD. Okay, then we have a quadrant, ACD. Quadrant means a quarter circle. Okay, 1/4 of a circle. Okay, that is a quadrant. So I know like some of the students, right, are not very good at terminology. Like when they see something like quadrant, like something like that, okay, then they will get a bit confused, okay, don't know like what the question is saying, okay? So quadrant means a quarter of a circle, 1/4 circle. Okay, with center at D. So this is ACD. Okay, let me highlight for you. ACD. Okay, this one. Okay, while ACB is another quadrant, okay, but with center at B. Okay, so I'm going to use another color for ACB, another color. Find the perimeter of the shaded region. Okay, now you notice something, okay? Both quadrants, they share the same radius because this is a square. So all the 4 sides are equal. Okay, quadrant ACD, okay, has radius CD or AD, right? CD or AD, okay? So similarly, okay, the other one, okay, the quadrant ACB, okay, ACB has radius BC, okay, or AB, right? So you notice that because all the 4 sides of a square are equal, right? Okay, both quadrants actually share the same radius. Okay, they have the same radius. So when we calculate the arc length, okay, we can actually combine. Okay, we can combine the 2 quadrants into 1 semicircle. Okay, when we consider the perimeter or even the area, okay, we can do that. Okay, so let's recall the formula for area and circumference of a circle. Okay, what is the area of a circle? What's the formula? Anybody? What's the formula for area of a circle? Okay, let me see. Gary, are you there? Oh, Benjamin say pi r square. Okay, fine. Okay, pi r squared. Very good. Okay, how about circumference? Circumference? Gary Lam? Pi d. Very good. Okay, pi d. Okay, pi d or 2 pi r. Okay, d means diameter. Okay, pi d or 2 pi r. Okay, in this case, right, we want to find the perimeter of the shaded region. So we are looking at the 2 arc lengths here. Okay, those the line highlighted in blue. Okay, highlighted in blue. Okay, so we are looking at these 2 arc lengths. Okay, so we want to find the sum of these 2 arc lengths. That means we want to find the perimeter, okay, of the lines in, not lines, the curves, okay, the curves in blue. Okay, but like I said just now, okay, these 2 can be combined, okay, they can be combined into the curved, or rather the arc length, okay, of a semicircle. Okay, these 2 can be combined into a semicircle because they have the same radius. So we can combine them into a semicircle, and this, okay, is actually this part. Okay, let me erase the bottom. Okay, so this part. Okay, so this part is actually the perimeter of the shaded region. Okay, so to find this part, okay, we just have to find the arc length of the semicircle. Okay, so we can actually combine, okay, because they have the same radius, so we can combine into 1 semicircle, right? 2 quadrants combined into 1 semicircle. So the perimeter of this shaded region, okay, perimeter of shaded region, okay, instead of taking 2 times 1/4 times 2 pi r, okay, we are just going to combine to one semicircle. Okay, so one semicircle, I just have to take half of the whole circle, 2 pi r. Okay, so 2 pi 16. I'm going to replace the pi, okay? I'm going to replace it with 22 out of 7. Okay, I'm just going to replace with this. Okay, anybody got any questions? Who wants to tell me anything? Usually I can't ask things like that. Anybody, any question? Everybody keep quiet. Then after that, I start to ask questions. Then people start to like, then I start to pick on people. Oh, you answer me. Then after that, start to realize, how come the concept is not correct? Okay. All right, so we calculate this. Okay, you usually you can use your calculator. Okay, it will give you the exact value in fraction. Okay, then you'll be able to get 50 and 2 out of 7 cm. Remember to include unit, okay, because it's perimeter. Okay, so it's a quantity, right? A physical quantity. So we need to give unit as well. Okay, moving on. Part B. Area of the shaded region. Okay, area of the shaded region. I think, okay, this kind of question, right, appeared in PSLE before. Am I right? Yes. Correct? Look familiar, right? Circles question. Okay, this kind of question, like half leaf. You all like to find half leaf, right? Half leaf and then find one full leaf, right? After finding half leaf, you find one full leaf. Am I right? How many of you actually did that for PSLE? Say yes if you ever did that. Find half leaf. How about the rest? Benjamin, good. Benjamin is like so lively. Okay, how about the rest? Yes. Okay, Kendrick. Okay, most of you actually find the half leaf, right? So y'all would do this, okay? I think a lot of you would do this. Okay, let me use another. Okay, how come somebody came in? Oh, okay. I use another color. Okay, say I use purple. Okay, some of you would do this. Okay, so you take, I take a ruler. Okay, so I place it here, right? So I draw the diagonal. Okay, diagonal AC. I draw this diagonal. Okay. Oh, there are 2 half leaves. 2 half leaves form 1 leaf. Okay, so I find 1 half leaf first, right? Most of you would do this. Okay, that's not totally wrong. Okay, so not saying it's wrong, like it's not wrong at all. Okay, it's not wrong at all, but it's just that it's more time consuming. Okay, so we look at method 1. Okay, method 1 is to find the half leaf. Okay, so we take a quadrant, subtract the triangle. Okay, so area of half leaf. Okay, you all like to do this. Okay, area of half leaf, then you take, the quadrant. Okay, so a quarter, then pi r square, right? So a quarter pi r square, then you subtract area of the triangle. Okay, so area of triangle ABC. Okay, area of triangle ABC. So half times base times height. Okay, because all 4 corners are 60, all 4 sides are 16, 16 like that, 16 each. Okay, so half times base times height. Okay, then after that, okay, you go on and find this value. Okay, so at this level, right, you can directly key in, okay, this whole expression, directly key into the calculator and press enter. Okay, the answer will come out. Okay, so then you get, say, 73, 1/7. Okay, then after that, okay, half leaf done. I need to find 1 leaf, right? So I times 2. Okay, so I times 2. Okay, so area of shaded region. Okay, area of shaded region. I'm going to take this and I times 2. Okay, so 1, 4, 6, 2 out of 7. 1, 4, 6, 2 out of 7. Okay, so this is like something that you learned, okay, in PSLE, right? So like I said, okay, all these are built upon, okay, your foundation in PSLE. Okay, so you cannot think that, oh, PSLE is over. That means everything is over. My entire school life is over, okay? Don't think that way, okay? It's not over. In fact, okay, PSLE is the, you know, like the pyramid, right? It's like the base of the pyramid, okay? So everything builds on that, okay? So you cannot let it collapse, okay? It has to be very strong. So if you find yourself like forgetting everything already, then you should go and revisit all over again, okay? Should like go and flip the books again, okay? Cannot let it be like, you know, out of sight, out of mind. Okay. Okay, so this is method number one, okay? Method number two, okay, method number two, right? This one, I want you to pay attention. Okay, method number two is faster. It is what it is. But it is what it is, okay? All right, method number two, right? You need to pay more attention, okay? Because I'm going to explain it, but I need you to try to understand, okay? So let me erase all these first. Okay, method number two is much faster and much easier, okay? I'm going to show you this. So I'm going to take this quadrant, okay, ADC or ACD, okay, this quadrant in green, okay, this quadrant in green, okay. So this quadrant in green, right, I'm going to name this part, okay, this unshaded part here A, and this shaded part, I'm going to name it B, okay. Similarly here, I'm going to name it C, okay. A and B makes up the first quadrant, ACD, all right. Now I have another quadrant. I'm going to use another color, okay? Maybe I don't shade, maybe I use like another color, say hot pink, right? I'm going to use hot pink for the other one. This is the other quadrant. Okay, so B plus C give you another quadrant. So if I add the area of quadrant A, okay, no, the area of the first quadrant in green and the area of the second quadrant in pink together, okay, if I add these two areas together, I will have one extra layer of B. Am I right? Okay, so you see, if I add these two layers together, okay, A plus B give me quadrant, okay, let me write down, okay? So quadrant ACD. Quadrant ACD is actually A plus B. Okay, so I have another quadrant. So another quadrant, say ACB or ABC. Okay, it's B plus C. So when I add these two together, I will have one extra layer of B. Okay, one extra layer of B because A plus B plus B plus C. I will have one extra layer of B. Okay, and A plus B plus C, right, actually give me area of the square. Okay, square. The square A, B, C, D, right, is actually A plus B plus C. A plus B plus C, okay, now A plus B plus C. A plus B plus C, okay, actually give me area of the square. Okay, so if I want to find this shaded area, right, this shaded area is actually area B. Okay, area B is the shaded area, the shaded area. Okay, so if I want to find this shaded area, I just have to take the sum of the two quadrants minus away the square. Okay, because when I take the sum of two quadrants, right, A plus B plus B plus C, okay, A plus B plus B plus C, okay, then I subtract away this. Okay, subtract A, subtract B, subtract C, then I will get B left. Okay, so this is another faster way. Okay, so we take the two quadrants, okay, one quadrant plus the other quadrant, in fact, they will form a semicircle. Okay, so I take the area of a semicircle minus away the area of the square, and then I get the answer. Okay, so that is actually a faster way. Okay, so in my working, right, I will present it this way. Okay, so area of shaded region. Okay, I'm going to take 2 times a quarter pi r squared. Okay, 2 times a quarter of pi r squared. Okay, then I'm going to minus away the square, 16 squared. 16 by 16. Okay, so 16 squared. Then I just key this whole thing into the calculator. Then I will get the answer directly. Okay, so actually, right, in fact, I find this is way faster. Okay, way easier. Okay, so usually, I mean, like, it really depends on individuals. Okay, but if you find like this kind of like this method 2 very difficult, okay, if you find that it's very hard to visualize, it's very difficult, especially in exams, okay, like during exams, you find it like so difficult to process like this whole thing, then you can use the half leaf. Okay, actually it's nothing wrong. Okay, nothing wrong to use the half leaf so long as, okay, remember this, okay, so long as your workings, okay, are coherent, okay, they are logical, okay, and they make mathematical sense. Okay, so long as you use the algebra correctly, okay, like you don't like make any mathematical, some people will have some misconceptions. So long as you don't like commit those mistakes, okay, then it's fine. Okay, so long as the steps are reasonable and valid. Okay. Desiree, hello Desiree. I see Desiree say hey to me. Hey Jer, I'm here. Desiree, do you skip your CCA? My dear Desiree, did you skip your CCA? Don't tell me you skip your CCA. You better not skip your CCA, okay? Okay, it just ended. Okay, good. Okay. All of you should, okay, just go do whatever you need to do. Okay. That, for example, if you're CCA, right, you should go for CCA. Okay, there are points. Michelle Lim said, I also skip. Why you like this? Why are you like this? You know, CCAs are also good for your health, you know that not? You see, right, some of you, right, okay, when you go for CCAs, you actually work out, right? Some of you actually work out during CCA, okay, good for health, all right? You don't skip, please, okay? There are CCA points, okay, attendance also. Don't just skip like that, okay? You need to meet your attendance. Okay, question number 2. Josiah say don't have CCA. Huh? How come don't have CCA? How is that possible? No CCA. You mean like suspended or like no CCA? Do you mean like, what do you mean by no CCA? Is it like suspended or like is it no CCA? Josiah say, I don't even have a CCA. I'm like, oh, suspended or what? Okay. Oh, suspended, I see. Oh, I got shocked. I thought, huh, no CCA at all. Yeah. Oh, Benjamin says, my parents asked me to go for the webinar because they don't want me to skip. My juniors are going to be disappointed. They have no seniors available. That's it. So more thing. Okay, this question. Okay. This question, right? Oh wait. Okay, I'm going to draw it properly. Like this. Okay. Okay, this question, I'm going to cut and paste. Okay, I think cut and paste is a method that you learned in PSLE as well. Okay, so we are going to cut this circle, okay, into 4 equal parts, okay, into quadrants. Okay, then I'm going to cut and paste, cut this, paste here. Okay, cut, paste, cut, paste. Okay, so I'm going to cut and paste until I form a square in the middle. Okay, so the total area, right, of the shaded region is actually equal to the area of the square. Okay, the area of this square here. Okay, so I can actually cut and paste because they are all 4 identical circles, but you have to make sure they are identical first. Okay, so they have equal radius, so they are identical. Okay, so identical means the same. Okay, the same. So if they are the same, right, then you can do the cut and paste. Okay, so the area of the shaded region, right, essentially it is just the area of the square. Okay, and the radius is 10. This is 10. In other words, one side is 20 cm. Okay, So the area of the shaded region is 20 by 20, area of a square. Okay, so 400. Okay, all right. Sometimes it's quite enjoyable to look at to read your comments. Okay, I think your comments are quite funny. You like okay, good, very good. Okay, keep the comments coming. Okay, otherwise, right? Because I can't see y'all now, you know, like through this webinar, I can't see y'all at all. I can't see your face, so I don't know, like yeah. So I feel like I'm just talking to myself. Okay, okay, good. All right. Okay. Next, okay, question number 3. Okay, question number 3. In the figure below, ABCD is a rhombus. Okay, rhombus meaning, okay, all the 4 sides are equal. Okay, 4 equal sides. So we have to recall the key characteristics. Okay, whenever we see that rhombus, right, recall all the key characteristics. Okay, 4 equal sides. Okay, and then if there is a diagonal, okay, if there's a diagonal, then the diagonal will bisect the interior angles. Okay, something you need to remember. Okay, and the diagonals are perpendicular to each other. Okay, so rhombus, okay, 4 sides equal. CEFG is a trapezium. Okay, trapezium. So all the related formula, we have to relate to them, okay, all the related formula. Okay, so area, okay, let's recall first, okay, say a rhombus. Okay, the area is base times height, okay, or one side times the perpendicular distance between that side and its opposite side. Okay, huh? Michelle Lim, I haven't finished the last question. Okay, the last question is only one step. Okay, 20 times 20, that's it. Can Michelle? Okay, just 20 times 20. Copy paste to form a square. Okay, and then it's 20 cm times 20 cm. Hope to see diamonds. What diamond? Trisha, chill. What diamonds? I hope to see diamonds. Oh, what's that? What side to side? Side to side. What diamonds? Minecraft song. Oh. Oh, Jing Xuan says cool. That song is cool, right? Okay, tonight. Okay. I see. Okay, so you're singing. So you're singing through the chat. I see. Oh, so you're actually typing out the lyrics, is it? Okay. Okay, so the total, the perimeter, okay? Perimeter is 4 times, okay, the length of one side. Okay, so the length of so we can say, okay, let's say the side is B, okay, the base, okay, it's the same, okay, so base times height, so B must be this, the length of one side, okay, so perimeter will be 4B. Okay, all right, next, if it's a trapezium, okay, if it's a trapezium, then the area, okay, the area will be half times A plus B times H. Okay, A and B are the lengths of the parallel sides. Okay, you can let one side be A and any one, okay, any one parallel side be A, the other one will be B. So A plus B times the perpendicular distance between them. Trisha. Okay, Trisha, can enough. Okay, I will listen to that song later. Trisha. Tristan raised his hand. Tristan, why you raise your hand? Tristan, raise your hand. Why? Why you suddenly raise your hand? Accident. I see. Wow, 1 billion views. Oh, okay. So later on, I will listen. Okay, I will listen to that song later. Okay, I have never listened to that song before. Okay, so I'll listen to that later. Okay, all right. So to find the perimeter, okay, to find perimeter, right, you just take the sum of the four sides. Okay, so you add all the four sides, okay, of the trapezium. Okay, so A plus B plus C plus D. Okay, all four sides. All right. Okay, so with that, okay, we are going to answer these questions. Okay, given that the area, okay, and perimeter of the rhombus have the same value, and you let one side be x, okay, you let one side be x, they have the same value. Okay, so the area, perimeter, okay, same value, the rhombus, okay. So one side you let it be x. Say I can let this, maybe I choose another color. Okay, maybe what color? Orange. Okay, I let it be x. So x, 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 like this. Okay, I let one side be x. Okay, find the height of the rhombus. Okay, let's focus on this formula. Okay, so if I let one side be x, okay, all the four sides are equal. So the base has to be x as well. Okay, so the base has to be x as well. So the area, right, the base is x. You let this be, base be x, okay, times h, times the height. Okay, base times the height, okay, must be equal to 4 times x. Okay, 4 times the base, 4 times x. All right, so by solving this equation, you see x is the same on both sides, right? X and x, x on the left, x on the right. Okay, so by comparing, okay, you can see that h, the height is equal to 4. Okay, the height is actually equal to 4 by comparing. Okay, x times h is equal to 4 times x. Okay, so h, which is the height, must be equal to 4 cm. All right, so this is by comparison. By comparison. Okay, part B. Given that the length EB is 25%, okay, 25% means 25 out of 100. Okay, we convert it into a fraction, which is a quarter. Reduce to simplest one, we get a quarter. Okay, it'll be helpful to convert into a fraction, okay, instead of leaving it as 25%. Okay, so we convert it into a fraction, we get a quarter. So EB, okay, is a quarter of EC. EC is actually the perpendicular distance between the parallel sides, okay, of the rhombus. So EC is actually the height, okay, it's actually the height, okay. Actually, don't need to like that, okay, it's really the height, okay, it's the height, okay. Because I just want to make it clear that, you know, when we talk about h, right, in the formula, we are looking at perpendicular distance, which need not be the height. It could be a length. Okay, so long as is a perpendicular distance between the parallel sides. Okay. So EB, part B. Okay, EB is a quarter of EC. Okay, EC is the height, which is 4. So it's a quarter of 4, which is 1 cm. Okay. So next part, okay, we need to find area of the shaded part. Okay, the shaded part is actually a trapezium minus a triangle. Okay, so you see this shaded part here. Okay, so this is actually a trapezium, right? So minus the triangle BEC. Okay, so this is a composite figure. It's not a regular figure. It's made up of like a regular subtract another regular. So it's a composite figure. Okay, so area of a trapezium, okay, is half times. So we follow the formula, okay? So we need to identify the parallel sides. So in this case, right, FG and FC are parallel. So you let one of them be A, the other one be B. Okay, one of them be A, the other one be B. Then you just use the formula. Okay, 6.8 plus 4 times the perpendicular distance between these parallel sides, between 6.8 and 4. Okay, so the perpendicular distance, right, 90-degree distance, okay, we are referring to this 2 cm here because you see here it's 90 degrees. Okay, perpendicular distance between these two sides. Okay, so 2 cm. Okay, so equal to 10.8. Then after that, to find area of the shaded part, okay, which is actually a composite figure, you just take the trapezium minus the triangle BEC. Two. Okay, which is 2. Okay, equal 8.8. Trisha says her brother's name is also Tristan. I've never met Trisha before. Trisha looks like a quite a cute person. Yeah. Josiah, I know Josiah. Josiah was in the MAP program. Yeah, but I've never ever met Trisha before. Okay, next. Done. Okay. If you are done, right? Okay, done with this question. Okay, not done like done. Okay, with this question, right? I'd like you to type Teacher Nicolle. Teacher Nicolle. Okay. Wonderful. Wonderful. Oh, scroll up a bit. Here. 李老师 Benjamin. Okay. Okay, done. Okay. I think who is still copying? Okay. Can Josiah say I'm not done? Can I move on? We have 10 minutes left. Can I move on? You know, we are having EOY crash course very soon, right? It's on every Friday from 20th of August onwards. Okay, 4 consecutive Fridays. Okay, we have EOY crash course. Okay, then I know my students, right? Most of you have already indicated your interest. Am I right? I think Desiree is one. I think Asher is another one. Yeah, I think a lot of you have already indicated your interest. Okay, so yeah, who else have already signed up? Huh? Michelle Lim is Asher. Seriously, Michelle Lim is Asher. Okay, I see. It's so confusing. How come it's so confusing? Okay, all right. I see. Okay. Okay. Anyway, doesn't matter. Okay, so I know a lot of students have already signed up. Okay, so I just want to let the rest, right, who have not heard of the program, okay, who doesn't even know that it existed. Okay, so anyway, there is an upcoming end of year crash course, a revision course. Okay, over 4 weeks. Okay, over 4 weeks every Friday. It's 2 hours each session from 4:30 to 6:30. Okay, so the first session will start on 20th of August and then 27th August, so on and so forth. Okay, yeah, every 7 days like that. Okay, so that's for Sec 1. Okay, Sec 2, right, if you have any siblings, okay, in Sec 2 will also be on the same dates. Okay, will also be on the same dates, but it will be at a slight, I think it's at from 4 to 6. I think it's from 4 to 6. Okay, then again, it's modular. That means that you can pick and choose the topics that you would like to attend. Okay, so that means, right, if you fail to attend the first session, it's still okay, because the next one is not a repeat of the first, or like it's not a like continuation of the first session. Okay, all of them are like separate sessions and independent of one another. So if you miss the first one, you can still attend the second or the third or the fourth, okay, depending on the topics that you are weak at and you would like to reinforce. Okay, that really depends on your own strength and weaknesses. Okay. Okay, so you don't have to attend, like it must be like all 4 like that. Okay, don't have to if you can't commit. Okay, if you can't commit due to CCAs or whatever reason, okay, then you can pick and choose. Okay, you can pick and choose certain modules to attend. Okay, question number 4. Okay, the 2 parallelograms PQRS, okay, BCDR are shown in the figure. Okay, this one and this. All right, they are parallelograms. That means opposite sides are parallel. Okay, maybe I use like that. Da, 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 da. Okay, opposite sides are parallel. Okay, parallel and equal. Okay, so the sum of the areas, okay, the 2 areas, the 2 parallelogram, okay, the total area is 940. So these 2 areas must add up to 940. If PQ equal to BC, okay, PQ equal to BC equal to DR equal to RS equal to half QB. Okay, half QB, that means, right, if I let each of these be 1 unit, 1 unit, 1 unit, 1 unit, then this QB has to be 2 units, because QB is half RS, okay, or PQ, all these are half of QB. Okay, so QB will have to be 2 units. Okay, find the area of the shaded region. So they give you the parallelogram and then they ask you to find area of the triangle. Okay, we need to spot some similarity. Okay, when we do math, right, sometimes you have to look at similarities and differences, spot some pattern. Okay, in this case, the parallelogram and the triangle, right, they share a common height. Okay, a common perpendicular height. Okay, in other words, the base would actually, the base as well as, you know, the half in the formula of the triangle would determine the difference, okay, in the area. Okay, so we have to see like what is common and what is different. All right. So the area of this area of, let's look at area of the parallelogram first. Okay, we have 2 parallelograms, so we are going to compare 1 parallelogram and 1 triangle. So we would take, okay, the total, okay, divided by 2. Okay, we are going to take the total and divide by 2 to get 1 parallelogram first. Okay, so we get 1 parallelogram first. All right, then this parallelogram, right, is base times height, right? This area is actually base times height. Okay, so base, the base of this parallelogram, okay, say for example, okay, since both are identical, I just take one would do. I just take the parallelogram PQRS. Okay, so if the area is this, okay, the base would be PQ, okay, or SR, okay. Then the height would be the common height that is shared with the triangle. Okay, so we let the common height be H. We let H, okay, be the perpendicular height. Okay, we let H be the perpendicular height from R to QB. Okay, so we let it be like the perpendicular height like this, 90-degree height. This is H. Okay, so you let this be H. So to find this parallelogram, right, using the formula, to find area of this parallelogram using formula will be base times height, which is PQ times H, which is 470 given. Okay. So we compare this, okay, with the area of the triangle. Area of triangle is half times QB times H. Okay. So the area of the triangle or the shaded region is actually half times QB times H. And QB is actually twice of PQ. Okay, PQ is 1 unit, QB is 2 units. Okay, so what am I saying? PQ is 1 unit, QB is 2 units. Yeah, okay. All right, so QB is twice of PQ. Okay, then times H. All right, these two, right? These, okay, can combine to give you 1. Half times 2 is 1. Okay, so combine to give you 1. So 1 PQ times H. And we know in the earlier equation here that PQ times H is actually 470. So we just copy that 470 and paste it here. 470. Okay, so this is how we get the area of the shaded part. Okay, 470. It's the same as the area of the parallelogram. Okay, okie dokie. Oh, just nice, 3:59. Just nice. I'm on time. I'm so punctual. Okay. Okay. By the way, just now at the start, right, there was some technical error. Okay, so because of that, we started a little late. Okay, but we managed to finish this. Okay, on time. Somebody say wait. Wait. You wanted to ask something? You all have questions that you want to ask? Nope. Okay. So if you are done, right? Okay, is everybody done with this? Okay, if you are done, please maybe say like what do you want to say? Okay, if you are done, right, then you can say like, see you again, teacher. If you are done with this, okay, if you are done copying everything, okay, learning this thing, okay, then please type see you again. Okay, see you again. I don't quite understand on the area of trapezium. Who is this? Somebody. Jessica, right? Jessica says, I don't quite understand on the area of trapezium. Is it the previous question? The previous question is area of trapezium. This one. This one. Which part? Jessica, which part? The area of a trapezium is a formula. This is the formula. Hey, hello, Trisha, please. The brackets. The brackets. Okay, wait, let me see. Brackets is this part, is it? Is this the part, Jessica? Oh, okay. Because for the trapezium, okay, you look at the formula here, right? A and B, right, refers to the two parallel lengths. the two parallel lengths. Okay, the sum of the two parallel lengths. So when you look at the trapezium, in this case, the question already says, right, that the trapezium is CEFG. Okay, that means the part that is highlighted in green, that's the trapezium. Okay, so the two parallel lengths are FG and EC. Okay, so FG parallel to EC. Okay, so FG and EC are parallel. So in this case, right, because they are parallel, okay, we can name one side, okay, one of them. You can let one of them be A, the other one be B. So in this case, I let this be A, this be B. Okay, FG be A and EC be B. So according to formula, right, I just take half times the sum of these two lengths, 6.8 and 4. Tristan, yes. Okay, the rest of you, right, if you are done, okay, copying everything, okay, if you have no other questions, you may leave, okay? Just type see you again, teacher, then you can leave already, okay? All right, thank you very much, okay? Thank you very much, everybody. Yeah, Jessica, can or not? Yes, thank you, Kendrick. Thank you very much. Okay, so up to here, is it okay? So this part here, right, is 6.8. 6.8 is the length of FG. FG is 6.8. Yeah, thank you, Benjamin. Okay, so EC, right, is 4 cm. EC is the height, 4 cm. So you take the sum of these two, which is here. This is A plus B. Then you times the perpendicular distance between them, the 90-degree distance between the two sides. Okay, so the 90-degree distance is actually 2 cm. 2 cm is over here. This is the distance. GC. GC is the perpendicular distance. Okay, between them. Then after that, you just find the value of this. Jessica, okay? Do you have further questions that you want to clarify? Then for the height of the rhombus, how to get 4? Okay, all right, because the question says, right, that the area of the rhombus is the same as the perimeter. The perimeter is 4 times the base. Am I right? Because all the 4 sides are equal, so 4 times the base. And area is base times height. And therefore, height must be equal to 4 if you equate the two. You see, this is B times H, and this is 4B, then H must be equal to 4. Because when you equate these two together and then you compare, H must be equal to 4. Okay, so you see here, okay, X, they say let one side be X. So when you let one side be X, right, X times H, this is the area. And the question says area and perimeter are the same. So this is the perimeter. So when you equate the two and you compare, right, X and X, H and 4. So H is equal to 4. Okay, Ken? Okay, any more? No more idea, right? No more questions. Okay, thank you very much, Jessica. Okay, all right. Who is this? Hello, Trisha. Trisha, what is going on, Trisha? Okay, Trisha. See you. Bye-bye, Trisha. Okay. All right, I'm going to end this already, okay? Thank you very much for your time, everybody. Okay, see you. Bye-bye.